Okay, hey, I have sound. Perfect. Hi, everyone. I'm Geir and Hjelle, and this is a tutorial about decorators. So, first of all, thank you all for coming. It's great to see so many here. And just to tell you a little bit about the plan today, I guess is that we'll talk about decorators. And the first part, I'll kind of be a little bit teachery and just stand here and talk and show you some examples. And then we'll kind of move into more of an interactive session quite soon, where you'll be sort of like given exercises, and then you'll have to play with them a little bit, and then we'll kind of discuss a little bit the solutions afterwards and move on different exercises. So before I start, just to sort of like get an overview, how many of you have written your own decorators before? So a few of you, okay. How many of you have consciously used a decorator? Cool. How many of you do not know what a decorator is? Perfect. Then we have a nice diversity here, and I'm sure that at the end of this, you'll all have written decorators yourself and hopefully have some good ideas about how you can use them. Okay, so my plan is to do this very interactively. So it looks like I have slides, but those are just the exercises. The rest, everything will kind of happen live. And also afterwards, I'll put everything up on my GitHub, so I'll share the GitHub link with you, and so you can find all the code I write afterwards. But it's kind of, the idea is that you'll be typing yourself as well. So, and then let me just see if we can get these things looking decently here. So we have, essentially I'll just be using an editor to kind of have some code displayed up there. And then I also want to have, let's see if we can make that work. Come there. Sort of like a screen like this. Okay. So here on the right-hand side, I'm running IPython. Let's see if we can make this there. I'm running IPython, which is an interactive Python REPL. If you don't have IPython installed, feel free to just type Python and use the REPL you have there. IPython brings a few niceties, like it's easier to find your history and move around and things like this. But everything we'll do is very much basic Python, so we can just use our REPL like this. In terms of colors, I guess I'll try to make everything, let's see, we don't need that background. So just to make sure everything is readable. Let's see. Turn off the transparency. And I guess I can also toggle this one. Okay, are the fonts big enough? Can you see them from the back? Perfect. Yep. Goody goody. Then we should be almost ready at least. Okay. So to start off, I kind of just want to give you a brief overview of what is a decorator. And then we'll kind of look a little bit about, it's really about how do you call and define functions. So we'll kind of talk a little bit about what are functions, how can you deal with functions in Python. So this will kind of just be a small overview like that. And then, as I said, afterwards, we'll kind of look into how do we actually define these things ourselves and so on. So first, let me just show you some examples of which decorators are kind of out there. And I'm going, at least in the beginning, we'll be using a lot of sort of like toy examples. So it may seem like decorators are for doing silly examples, but they are actually quite powerful, and you can use them for real stuff as well. But yeah, bear with me with some of the toy examples in the beginning, I guess. The idea is that I've chosen them more for their explainability, so to speak, than their usefulness, at least the first ones. Okay, so I'll start off just by importing the time library, mainly because I just want to show off something that's slow. And instead of creating a function that takes a long time to run, we'll just do the easy thing and do a time sleep in our function. And for this one, I want to just define a function that I'll call a slow square. So it will take in a number, and then it will square that number. But it will do so very slowly. So not very useful necessarily, but it can show us some of the things that we'll use. So let's see. Let's start off at least by saying that we'll be sleeping for a given number of seconds. So yeah, just to be clear, this is an F string. Let's see, I'll make this one slightly wider for now, and then we'll put it back in again. So just to let people know that something is happening, and then let's actually sleep. So I'll just sleep for some given number of seconds, and then we'll actually do the job of squaring the number. So this slow square function, it just squares a number, but very slowly. So for instance, we can square the number 3, and after 3 seconds, we'll get the number 9 out. I don't want to really go on square very big numbers, because that will take a really long time. But you can see here, every time I call this, it takes some time. Now, think of this more as you're doing some operation, you're doing some function that actually takes time for normal reasons. So you may want to avoid doing that operation over and over again. And Python comes with one of the standard library decorators, which is called cache. So this one you can use to cache results, which essentially means we've already calculated this. So just recall the result from previous. And one way we can use this is that I can define a cached square. Let's see. Which I'll just define by applying this decorator function to my slow square function. So for now, we don't really know what this cache is doing unless we go read in the docs or something like this. So it may not be clear that this cache can be applied to a function like this, but for now, let's just trust that this works. So you can see here what actually has happened is that I've added slow square, or I applied cache to slow square. And let's see the result of this. So if we now call cached square with 3, then we can notice that again, it sleeps for 3 seconds. So it again takes a little bit of time. But now if I call this a second time, you can see I get an immediate result. And it's not printing out this sleeping for 3 seconds at all. So what it has actually done is just completely skipped the second invocation of my function, because it knows the return value is 9 when it calls it like this. Now, if I change the parameter here, so I'll do watch the square of 2 instead, then we'll see that again it goes back to sleeping, because now I had different parameters sending in, and then it sleeps for 2 seconds, and then we get 4 back. But then now this is also cached. So if I call cached square, I get this immediately. And it has some memory, so if I go back and calling cached square 3, that's also immediate. So all of this last stuff is not really about the decorator. The decorator part is just cache is a decorator. So what can decorators do? They can kind of change functions from the outside. So right here, I didn't do anything to my slow square function, but I changed how the slow square function works, right? Instead of being slow at every call, now it suddenly caches the results. And I could do this without going in and changing the function itself. So that is typically what we use decorators for. It's kind of we can apply some behavior or something to different functions. So different examples of this would be, for instance, if you have setting up some website, you can kind of say that some of the routes you're going to, you need to be logged in, and some you don't. And you can kind of put the login logic in the decorator, which makes it really easy to just say, these are private pages, these are public pages, for instance. Or maybe you need to time certain functions. You can have a timer decorator that can just time things. One example we'll play with a little bit later is that maybe you have some function that sometimes fails, so you just want to retry. So then you can kind of retry until it succeeds, and so on. Different ways where you can just add some behavior outside. A very powerful one, I guess, from the numerical analysis thing is that you can say that I want to apply just-in-time compilation to a function so that it can run faster. That's also something you can do just with a decorator. Okay. I'll also now very briefly just show you the typical syntax for using decorators. Because if you've seen decorators, they usually don't look like the one in number 6 there. That's one way to decorate your functions, but usually you do it when you define the function itself. So we can also define the cached square. Let's see, we can do this on top here. With this @ symbol. So @ symbol cache means that now I'm applying a decorator. And then I can just type out my function here. So previously we called it slow square, now I'll call it cache square like this. And then I can again, I'll kind of just repeat the same code like this. And now we should have exactly the same behavior as earlier. So if I call cache square with 3, it sleeps for 3 seconds, but the second invocation is immediate. So this is kind of the typical way that we'll use decorators. Okay, I guess I didn't say this when I started, but feel very free to shake your hands in the air and ask questions. I'll try, so for video purposes, either I'll have to repeat the question or there is a microphone up there as well. So if you want to stretch your legs, you can also go up to the microphone. But yeah, do stop me if there's any questions. And I guess when we're talking logistics, there should be a break in about 1 hour and 18 minutes. So we'll have a half-hour break, sort of like in the middle of the tutorial. Yes? So you're asking, well, previously I imported cache from functools.
Yeah, and then we created a cache square equals cache.
Yeah. Right, yeah. Yes, exactly. So let's see if I find that one. So here I had this, and then the first thing we did was this, right? Yeah, so first I imported cache, and I used it there. And then what happened when I did number 12 up there is that I overwrote that function. So I kind of just redefined it with the exact same behavior. So it's kind of, right, no, but yeah, you can see, I guess here I renamed the slow square to this cache square. So then yeah, so they are kind of different, but the end result is the same. Yeah. What's the cost of essentially doing the decorator thing?
Yeah,
yeah.
You could potentially just add cache to every function you ever wrote.
Yeah.
Call it twice.
Exactly. Yeah, I guess there's 2 questions hiding there. So one is what's the cost of applying decorators, essentially? And those, I believe they're not very much optimized. So essentially it is an extra function call. And function calls take time in Python. So there is some penalty to using decorators in general. In particular, in terms of the cache, why don't we just cache everything? And that may be a good idea if you know that all your functions don't have side effects. For instance, if you could see the print statement disappear there. So if you kind of need all your function calls to have some side effect, then caching won't really work. So, and yeah, caching can lead to very subtle bugs, and so you'd really have control on them being pure, I guess. Okay, so now we've seen decorators. Then now I kind of want to take a step back and start talking about what's a function and how can we play with functions. And I guess, let's see. Yeah, the question is not so much what's a function. I'm kind of assuming that you're familiar with doing your def something with parameters. But what can we then do with these things? So typically, at least, when we define a function, let's just do something like a double there, and then let's just return, well, not this, x times 2. So here I've defined a new function that just returns the double of whatever is passed in. And what I guess at least not always true in all programming languages is that in Python a function is again just an object that has a named reference to it. So for instance, if I just type out the name, you can see here that it kind of references this function object that's there. And then we can see that there is a difference if we have, if we just type the name and if we type the name with parentheses. So if we just have the name, and this will kind of be important for the rest of the tutorial. So if we have the name like this, that's just a reference. But if we add parentheses, then we're calling the function. And what we get back is then the result, the return value from that function. So you can see here in number 17, I'm getting the function. In 18, I'm getting the number. That's the return value from there. But since these things are kind of just named references in this sense, it means that we can also redefine things and so on. So for instance, I can do something weird like this, where I'm saying that skriv ut equals print. So skriv ut is Norwegian for print. So this is me starting to translate Python into Norwegian. And we can see now this skriv ut here. If I ask it just what you are, it is the print function. And I can use it to say something like, hi, Python. And it prints this out for me. So that's kind of one thing we can do with functions. We can give them different names if we want to. And this is kind of now just both print and skriv ut are both functions that kind of just reference the same function objects. So they are identical, how you call them. Of course, this is probably not a good idea if you kind of want to have your code been read by others and so on. It's also then, we can kind of do the opposite, which is probably also bad. But I can reuse print as a statement like this. And we can see now this has become the number 3. And I can't really call, let's see, 2 plus 3 or something. We can see now that this is actually a number, so I can't really call it like this. So it kind of just lives in the same namespace as regular variables. So you can kind of need to take care that your variables and functions have different names and so on. But if I delete my variable, then I get back the built-in here, so we can, I guess, play with it. Okay. So we've seen that functions behave very much like variables, objects, those kind of things. And we can also then use functions as arguments to other functions. And now we're getting close to the whole decorator thing. Like you saw earlier, we did the cache of a function and returned a new function. So let's play with this a little bit more before we go to the decorator world. So let's say that we have a greet function. And this function takes in, yeah, let's keep it like this, a name and a greeter function. And then it just does, I'll do something like this. So I'll call the greeter function, and you can see here that this greeter function is passed in, so it's one of the parameters. And then it just calls that function with the text hi name. So how can we use this? Well, I could then say something like hi PyCon, I guess. I can greet PyCon and say that I want to use the print function as my greeter function, like this. And then you can see it prints out stuff. So what happened here is that we're taking print over there, it's passed in there, so this greeter of something is actually just calling print. And since we also gave print a different name, I can also use the skriv ut greeter for it. So there's really no difference whether you pass a regular object like a text or a number or a function. And yeah, to kind of play a little bit more with it and try to see the nuances of what's happening, let's also define a new function I'll call tnerp. And anyone want to guess what the tnerp function should do? Print backwards, there we go. Perfect. So it will just print our text reversed, like this. So if I, for instance, say nerp hi there, I'll get out Retry or something like this. Now, of course, we can use our greet function. And instead of using PyCon like this, I can just use the tnerp function. And we can see that it then prints out hi PyCon backwards, right? So we can see that we're kind of passing through the function there. Okay. So let's see, so far we've kind of figured out we can pass these functions around. It means we can actually also define functions dynamically. So far we've just defined functions kind of with our def statement, but it's possible to define a function that defines another function. So sort of like a function factory. As an example of this, I'll call it a prefix factory. And the way that we define these dynamical functions is that we'll just sort of like add in a new function in the middle of this. So in nest functions, we often call them inner functions. So we define an inner function. So inside of the prefix factory here, I'll just define a prefix printer, I guess I called it. Yeah. And with this one, I'll then just print out the prefix and the text. So untangle the syntax there in a little bit. And then what I also want to do here now is that my prefix factory returns this inner function. So if you've never seen these inner functions, it may look kind of weird that, okay, I have a function, then I have another function within there, and then what I'm actually doing at the end there, so my factory function returns the inner function. And first of all, let's just have a look at this. So prefix printer seems to be a defined function now, but I can't call it. So it's defined within that other function. And in some sense, it's not really defined here at all. It's kind of just living inside that function. So we see we can't get to the prefix printer function there. But I can, let's see, get to, let's say that we create the prefix here that I'll use for debug. So if I just call this, we can see the return value of this is now some function that has a fairly weird name over there. But you can, if we stare at this for a while, we can see that, okay, it belongs to prefix factory. It's sort of like the locals of there, and then it's this prefix printer function comes back out. So that means that I can use my factory to define new functions. So if I do this, I have now defined a function, and I've given it a name, so I can reference it. And then I can say something like debug, well, let's say hi PyCon, for instance. And you can see now the result of this is that it prints out our debug prefix in front and then the text we pass in. So now, let's see, okay, so we lost the text up there. I'll go slightly back there.
Do you maybe want to make it full screen?
Yeah, I'll no. I'll soon start using that side. So, yeah, so the prefix factory, if we look a little bit at this, see if we can figure out what happened here, is that our prefix factory, so the prefix printer function is only defined each time you call the prefix factory. And each time we call the prefix factory, we create a new function from this. And then one thing that might be weird is that this prefix variable comes from the outer function, while the text comes from the inner one. So what we really do there is that we kind of enclose the value, so we kind of have, I guess it's called a closure, where your prefix value is stored, so that the debug function that we create down here knows that for this function, prefix is always debug, while the text can change for every invocation. So we saw here that we did hi PyCon, but I can also say something, well, I can say something else, and it will kind of print out that. So the prefix is fixed, but something else changes. And similarly, I can create a warning function, and then our warning function will again then have these changing texts, but a fixed prefix that is different from the other prefix. So in some respect, the debug and warning function, they're the same function in the sense that they're both this prefix printer function really, but their behavior is slightly different. Okay, let's see. So now, I guess we can also just check out, since we have a new function, we can pass it to greet, and we can see that, okay, our greeter debug also works with this. So we can pass in kind of any function where we can do these things. Then let's see, so now we had a factory that could create new functions, but we can also play with this and create a different factory that kind of takes in functions. So let me just look up my notes for this. So we can also create a different type of factory where instead of just having the prefix factory had this fixed text there, but that can also be a function. So we can kind of have a function that depends on a function in a sense. So let's see how that would look. So I'll define a reverse factory. But here you can see instead of just taking in a text, I'll take in a function. And what I want this thing to do is that it will kind of just reverse. So it's just similar to that NERP idea we had, that it can kind of, just reverse whatever you give to it. So my inner function here, I'll call a reverse caller. And this will then just call a function like this. So the factory creates a function that can kind of call things with the parameter reversed. And then we need to do this, the same thing, since we don't really have access to reverse caller, we need to actually return that back out of the function. Okay, return reverse caller. So let's just check how this works then. So first of all, we could do something like reverse factory. And if I then pass in the print function, for instance, then we see that, okay, I get out this inner function thingy. And this is a function, so I could directly call it like this. And you can see that it has actually, it calls print, but with stuff reversed. But again, to kind of keep this more or less traceable what we're doing. I'll give a name to this. And then our reverse print function, we can call this and we'll see that it returns, well, it reverses the arguments that we have. I could similarly apply this to some of the other functions we have defined. So for instance, I can do a reverse NURP. And let's see, what would the result of this be? HiPyCon, yeah. So we're reversing the reverse, so we get back to this one. Okay, so now let's see. I want to, let's see. Yeah, I should, let me actually briefly just copy a few of these. So this is our reverse color. And I also want the prefix factory, I guess. And then we'll see if we can fit stuff on screen. Okay, because now I want to do a reverse debug, which will be reverse factory of debug. And then we'll call this. So anyone wants to take a stab at guessing what the result of this last call, line 14, will be? And it's okay if you can't pronounce it, I guess. Well, let's. Right, okay, yeah, so debug will be forwards and then HiPyCon should be reversed. Let's have a look. Okay. I'll do this. So there, okay. So debug, HiPyCon. That was not what we wanted, right? We wanted reverse debug. And actually, did I? Yeah, apparently I fooled both myself and everyone else there. There we go. So yeah, debug for some reason is not reversed while HiPyCon is reversed. And this is, of course, when you start applying functions to functions to functions, keeping track of which happens in which order is not trivial. But if we trace this, I guess, let's see if we can put stuff on the same screen there. Let's see, yeah. What happens when you call reverse debug HiPyCon here? Let's see. This becomes the parameter that goes into the text there. So HiPyCon is reversed over here, and then that calls the function, which came from somewhere. That's the prefix printer function that then sends the reversed HiPyCon part in. But debug is not reversed since that was already a part of that function. Right? So that's kind of the story there. Okay, so now we've kind of gone sort of like off the deep end a little bit with functions and calling functions and stuff like this. So now let's wrap this back up together and see what it has to do with decorators. And in a sense, we're kind of already there because this reverse factory is a decorator. And then what is a decorator? So let me see. So I have it over here. A decorator is just a function that accepts a function as a parameter and returns back a function. So it can kind of has the power to transform a function, essentially. So you can see here with the reverse factory, it takes a function coming in there, and this reverse caller thing is a function, so we return another function. And then you have a decorator. So now we have created our first decorator. That means that we can use this. So let's see if that actually works. So first, I'll kind of define a simpler version of greet that I'll just say hi, and it just says hi, like this. So now we kind of, oh yeah, I got the wrong, we need our f string in there. So when we're calling this, this is kind of what we've seen a bunch of times already. We print out hi PyCon. And now I can essentially apply the decorator similar to what we did with cache in the beginning. So I could say something like hi equals just this reverse factory of hi. And then here we kind of see the same effect that we had with debug, that it reverses the parameter that we're sending in here. So we get hi, no zip. But this, we talked about, this was kind of the syntax for decorating, which it really tells you all you need to know about the decorator, if you kind of know this. But then we have this nice syntactic sugar, where I could instead just spell it out like this. So let's see, print hi like this. And now if I do hi PyCon, we have the same result. And kind of, yeah, just to show you that this actually is, since I get the exact same result, right? So let me also just do a hello instead, just to show that it does the work. And we need a colon. So, and this function should say hello. Something like this. If I say hello PyCon, we can see that it still applies the reverse factory there. So, in a sense, you know everything that I'll teach you about decorators now. That's kind of, that this is kind of how you apply decorators, but the effect of it is really just that it's doing this thing. So whenever you're kind of wondering what's the effect of doing in a decorator, you can try to unravel it into this, and then that kind of is easier to figure out what's happening, while this is kind of the nicer syntax for it, in a sense. So, let's get to the place where you also get to do some work. And I'll, let me think. I'll first just say 2 words about decorators, and then we'll show some exercises. Yes? Right. So the question is just about, essentially, here it seems like we're doing it as part of the definition, while if we do it like this, we're doing after the function is defined. And that's completely true. The 2 things are kind of, they're equivalent, except for the fact that you kind of have this intermediate step where you have the function, this temporary function, so to speak, defined. So that's not defined in this case. So we'll play a little bit more afterwards with seeing how sort of like this at reverse factory really happens at define time, compile time, more or less, versus at runtime, which it more or less seems like we're doing at 65. But let's see, decorators were introduced in Python 2.4. And before then, there were actually a few decorators introduced. So you may have seen, if you've done some object-oriented programming, there is a static method and class method decorators. So those were actually defined as decorator functions in Python before decorator syntax existed. So when you used these statements in, say, Python 2.3, then you would have to kind of do what we did at the end there. And that was kind of observed as kind of being some frustration, some friction with kind of using this, is that you first define your function or your method, and then afterwards you need this weird step of adding that this is a static method. And one thing I guess we can at least to some extent see out of this as well is that if we're doing, yeah, let me type it out completely. So if we're doing the hello there, and then we're doing this thing afterwards, then to define a function like this, I have to repeat the name 3 times, which feels very wasteful in a sense as well. So this was really the motivation. We need a nicer way of doing this. So as you can see, even without the typical decorator syntax, Python already had support for functions as first-class objects and things like this. So you could kind of, we could kind of always do this, but then adding the special syntax was kind of what happened then in 2.4 and when kind of I guess decorators were more popularized in a sense. This happened with PEP 3.18. So I don't know if all of you know the PEP process, the Python enhancement proposals. But this is sort of like a formalized way of introducing new features to the language. And it typically then happens with a lot of discussion online. And it's somewhat fun to be reading these PEPs and look at what were discussions about how to do the syntax. And it seemed like everybody was in agreement there about, yeah, we definitely need a nicer syntax for this. And then, of course, everywhere in total disagreement about what kind of syntax should we use. So some of the suggestions for this was that, or I guess the argument against the syntax they ended up with is that this is the first and possibly still the only syntax where one of these lines directly applies to the line below it instead of kind of, I guess we have things like, okay, we start a block and stuff like this, but here we just have a weird line of code that kind of floats by itself, and then it has a very significant effect on the line below it. So there were some attempts at, okay, let's try to put this decorator syntax in the middle there. So I think one suggestion was, let's write something like reverse factory hello. That the syntax would be something like this, which potentially could have worked as well, right? It's kind of, we just need to make some choice. This will, of course, not work now, so I guess, yeah, it starts yelling at me at some point. And I think there were also some discussion, should we use the @ symbol, which were not used in Python before, or should we reuse some of the others, and so on. But at least in the end, we found a syntax, and then I guess at least we've gotten used to it. Since the decorators were introduced in Python 2.4, there was very little change to it. It's kind of just been a syntax that works. One slightly weird thing maybe when they defined the decorator syntax was that they somewhat artificially limited what you could do. So what we've seen so far is that here we're just spelling out this function. In theory, this could have been, say, a class method or something like this as well. But that was kind of explicitly disallowed in the beginning. So in Python 3.9, I think, they just lifted all of these weird limitations and said that anything that's callable, more or less, you could put in there. So now, I guess it's theoretically possible at least to use a lambda or something there as well. But in general, this is still the way that you typically will use them. Okay. So now you've seen a little bit of what decorators are. We'll definitely return to this much more. But I think we can try to give you a small exercise. Let's see if we make this work. And let me see if I'm able to do a couple of things at once. So the exercise, and I'll kind of give you some time for this, is that you'll write your own decorator, and it will not do anything very spectacular, but it will print out before calling your function, and it print out after calling it. So you should name it before and after, and to test if it works, you can kind of just implement this test and see if you get this result. I have also, and let's see if I'm able to show this. See what happens here. And this, yeah, feel free to do this if you like it, and feel free to ignore it if you don't. But let's see. Why is this not working? I have created, okay, let's see. There we go. Gotcha. So this is probably the simplest Google form ever. But if you want to kind of share your code, feel free to just drop it into here. Unfortunately, links to these Google Forms are not always trivial. So, but yeah, so you'll get a little bit more extra effort as well, that you need to figure out how to type in those letters. Sorry. But yeah, the important thing, have fun with the decorator. Just a quick note, if you don't want to type in the link stuff there, you can also find my GitHub. It's, let's see, GA Hjelle, and then just maneuver to Decorators Tutorial 2023, and the link is there as well. Cool, I'm seeing quite a few responses already, so I guess at least a good portion of you have gotten this to work. So I guess we'll pick it up from here, and if you're still not finished, just feel free to play with it, and then we'll discuss the answer here as well. So let's see, what would one of these decorators look like? And I see most of you have kind of come up with the same answers, so let's see. I'll get this thing back on the screen here. So exercise 1. So what we need to do was to create this before and after decorator. Before and after. And what we talked about is that a decorator is a function that takes a function in and returns some other function, or some function, I guess. Doesn't need to be another one. So I'll just call that func here. And then what we've kind of seen a little bit in our example so far is that this inner function, it's not really exposed, I guess, to the end user in the sense that they don't need to know the name of what to call it, but it kind of leaks through a little bit here and there. So sometimes it's okay to have some kind of nice name for it. We'll soon see how that we can avoid leaking the name of these things as well. So what I tend to do is just end up calling this thing a wrapper, but you can kind of give it some name that makes sense. But yeah, I'll do a wrapper here. And then in our example, let's see, or our exercise, we want this before and after to then be able to print before and then run on this high Python thing and then print afterwards. In the example, we used this high function that we've been seeing. So we kind of come down to a question, what should the argument to wrapper be? And if we're really designing it just for the high, what will end up coming in here is this name parameter. I'll pretend to be slightly more generic by writing text there, but that's just a name, so it's really not more generic, and we'll discuss some of the issues with this soon, and then see how we can make this even better. But let's stick with this one for now. And what kind of will happen is that this wrapper function is the one that kind of replaces the high function, right? So this is where we need to do the print before and print after. So the first thing we'll do inside of this wrapper is that I'll just print out before like this. The last thing I'll do is that I'll print out after. And the thing I'll do in the middle is to actually call the function. So we can call this, and then I name this text in this example. And then I need to have my decorator, so that's the before and after thing, then return this wrapper function. So if we kind of end up with some code like this. And part of the reason I kind of wanted to show this still fairly basic and completely useless example is that it kind of shows you the typical template for your decorators. Typically, you want to use a decorator to either do something before you call a function or after. So you kind of end up with something that, in principle, looks like this. So you kind of do your stuff before, you call your function, you do something afterwards. And yeah, I see most of you kind of come up with something that looks like this. Many of you have found something that's even better, so we'll continue to improve on this soon. But let's check that this is actually something that works. So I'll copy this code. Let's see. There we are. So if I have this, and then our test was that we wanted to apply this to a high function, not the hello function. So now if I do high PyCon, we can see that it does what we wanted it to do. You get the before, you get high PyCon, you get after. Yep. Okay. Yep.
And then when I provided a parameter, it worked. But then when I didn't provide a parameter, even though it was default there, it worked.
Yes. Perfect. I like that. So Glenn here tells me that he'd added a default value to name. So let's see what happened then. So if we do before and after, and then we have a default value here. So I'll have this one greet myself by default. And now, I guess our high PyCon still works, but if I just do this, then we can see we get something wrong happened. So what is that wrong thing that happened? So we can see if we kind of stare at this error message here, it says that before and after wrapper is missing one required positional argument. So our wrapper, let's see. Oops. So this wrapper function requires one parameter. And when we call high with no parameters, we're really calling wrapper with no parameters, because wrapper has replaced our high function. That's kind of the declaration. So the error message comes because this one doesn't have a default value. But it also kind of points to the fact that our decorator is not very flexible. And to kind of show you a different example of this, I mentioned earlier, I guess, that decorators are these things which you can apply to any function, and then you can change the behavior of it. So for instance, I mentioned, I guess, this JIT compiler thing that can compile any function. Maybe we can time any function and so on. But here in our decorator, we hard-coded that this has one parameter that we name text. And that kind of causes some issues for us. So just to show you a different example of this, let's do this fairly silly example, because we have a plus operator in Python, so we really don't need to do this. But again, it kind of just shows us that we can, say, add two numbers like this. But now if I decorate this with my before and after, I'll have the exact same issues that we had earlier. So let's see if we do before and after, and then I'll do the same thing here. And now I call this. Again, I get this error message thrown at me. And again, it's kind of because this wrapper takes only one argument. In this case, I gave it two. So what can we do with our decorator to make this one work better. So what it comes down to is that we really want to have this thing work independently of how many parameters are passed into it. And to do that, we'll use, I guess, the star and star operators, which are often just called args and kwargs, which are just weird noises we're making. But if you, so let's have a look at what those do first, and then we'll figure out how to use them in here. So we can define a function, and then just use this for our parameters. And the important part here is actually the stars. The names are not important, but they kind of, unless we have better names, then we typically end up with calling them args and kwargs. So the args there are just the arguments that you're passing in without the name, and then kw, those are keyword arguments. And just to show these things, I can, let's see. I'll add a few f strings, which also gives me the opportunity to show off. I don't know if everyone's familiar with this f string syntax, but it's kind of neat. So play with that. So these two lines of f strings, when I throw in an equal sign there, it will print both the parameter name and its value. It works on Python 3.8 and later. So. But if I now call this function, and let's say I'll stick with my high PyCon thing, you can see here that in this case, args here is a tuple with one element that is my first argument there. And if I would give this a name, so maybe I'll say greeting there, then you can see that what comes in here is instead passed in this kwargs. And the kwargs is a dictionary where your parameter name or keyword is the key in the dictionary, and then the other thing is the value. And then we can have a mix of these. So I could, for instance, have 3.14 there, and maybe I can have things like this, and yeah, just for fun, let's, guess I can do this, and e equals 2.7128. So as we're kind of passing in more and more of these arguments, you can see they're collected either in args or kwargs, depending on whether you use the keyword arguments, like I did for the last two ones, or just pass them in as values, as positional arguments. So this is typically how you then can create functions that take either a variable number of arguments or things like this. And that's really what we need for our decorators. To show you just quickly, I guess, a more practical example of this, I'll also do a new version of my adder function. So I want my adder function to be able to add up any number of numbers. And in this case, we could potentially just say that I want everything in as a list. But if I do this thing here, now I'm saying that I want at least one number, and then from 0 to infinitely, I guess, in some version of infinite, numbers, which will then come in as this args thing. And here also you can see that it's the star that kind of is the syntax, not the name args. But whatever I put there kind of comes in as this similar tuple. And what I can do now is to say that, okay, if I'm not getting any numbers, so that means I'm only getting one number, really, then this is empty. Then the sum of the number is just a number. So I can just return number. And else, let's see, I can return number plus the sum of these numbers, something like this. So this now, it's not really anything about decorators, just to show off the star syntax. But But here you can see that I can now add one number. That's just the number itself. I can add two numbers. I can add, I don't know, three numbers, and so on and so on. So this is how you can kind of create these more flexible function arguments. So let's see, how can we use this now in our decorator? Any questions about this, by the way? No? Okay, then I'll jump back to our before and after function. And what we saw was that we got issues with wrapper being insistent on only taking in one argument. So this one we can now replace with our args and kwargs. So the way we'll do this is that we'll just throw in args and kwargs like this. And then when we're calling the function, we also need to do the same, pass them back out again, essentially. So with this definition now, before and after, we should be able to make the previous examples work. So let's try it. Let's see, so then we had our before and after with the default value for high. And let's see, this one. Looks something like this. So we've already seen that it will work if we kind of just use PyCon. But now we should also be able to get it to work with the default value. So what happens here, and let's see if we can pass this through, is that high, when I'm calling high there, I'm really calling wrapper. So wrapper up there, if I call high like this, the args will be empty, the kwargs will be empty, and it means that it prints out before, and then it calls this function without any arguments. So that means that at that point, the default value triggers. And then it's able to print out Geir down there. And now we can also do the before and after on this adder function. Before and, yeah. Right. Okay. Yeah. Good point. So the question was essentially, what if I have more arguments to high, right? So high, if we throw in something like this, yeah. This will not work, and that's kind of the same as because let's see, our high function can't take two arguments. So the decorator can't magically make a function suddenly do other things like that. What's actually possible, well, I don't know if we'll get to that, is that you could kind of have your decorator eat up some arguments. So typically what you want to do is essentially follow this template where you just take in the arguments and pass them back out again. But it is definitely possible to say that here I'll eat up an argument and not pass it on. So for instance, I could say that I'm eating up the name argument and not passing it into this function. So it's possible to do weird stuff like that, but it's seldom useful, at least. No. And let's see, yeah, just to wrap this up, I guess we can also check now that our adder function, let's see the previous adder, the simple adder, so number one, this one. So now we have two arguments, but now this should actually work. 23 and 10. Yes. You can see it prints out before and after. It didn't print out the answer, and it didn't return an answer. So that's actually another thing that we haven't really fixed yet. because let's have a look at what happens to the return value. Let's see, there's a wrapper. Yeah, so what we've done so far with the high function is that we printed out stuff. So we've seen the print stuff. What you typically do when you're passing stuff around, right, is to return values. And if we look at this wrapper function, it doesn't return anything, which means that implicitly it returns none. So we're actually killing off whatever return value we got from this one. So that means that we're still not done. In that sense, we have something that kind of destroys our functions. So let's see if we can add that as one more improvement. So what we actually need to do is to also collect up the return value of this. Not value, but value. So if I store the value there, and then I can return it here. So since I need to do something after my function call, I need to save the return value, and then I'll explicitly return it down there. So let's see how this behaves. So I'll go back to this one, and then let's try to define our adder one more time. So now we can see that I get the output at the end there. So we preserve the value. You can, I guess, the return value from a function always comes at the end, even if we kind of decorate it like this, at least as long as we're keeping stuff synchronous. So we can see here that before, after, the actual adding calculation happens between before and after, and then it kind of returns the value after it's kind of done cleaning up or whatever the after operation is. So what we have on the top there now, that is really, well, there'll be one more improvement, but it's essentially the template that you'll kind of end up using for most of your, at least basic decorators. So if you can kind of just define, okay, there's something I should do before calling the function, something I should do afterwards, and then just put it in where we have the print statements right now. Let's see. Yeah, we have 15 minutes until the break, so I guess that's a good point to do another exercise. So let's see, do we have... so in this one, we're gonna, you can kind of reuse the template that we've created now, but see if you can write a decorator that runs this decorated function twice. So if we, for instance, had this high function, it should then say hi PyCon. And then now we kind of got to know that we need to care about these return values. And when you run a function twice, it's not clear what should be the return value of this. So somewhat arbitrarily, I'll say that you should return a two-tuple with both return values. So if we implement a random roll dice function, then rolling this with the do twice, you should get back two numbers. And again, feel free to share the code in the same Google form that you played with earlier, then I can kind of see what comes in. Cool, yeah, so I'm starting to see some responses again, so I guess we can start looking a little bit at this. And yeah, we're still at these decorators that are kind of silly. I don't know if there's a very good use of this do twice thing, but let's see if we can figure out how to implement it at least. And in this case, we'll kind of have a look at the template that we kind of came up with for before and after, but we can see that we can kind of cut away several things for it. But I'll start sort of like with the typical, my do twice, and it takes in a function, and then I know I'll have a wrapper thing inside of here. And as we discussed, this wrappers will typically always have your args and kwargs just to be flexible enough to be applied to anything. And now our task was that we wanted to call func twice and return the result as a tuple. So we could kind of be fairly clever with this and just do, let's see, I'll return args and kwargs, and then I'll add in a comma and call it one more time. And then I just need to remember to return this wrapper function. So this is kind of the maybe too clever version of this. So here I'm calling func, and then I'm calling it one more time, and I'm just returning the results as a tuple. So let me see. I can start by just proving that it works, and then we can see we can write it more readable afterwards. But let's see. I want to import random since our test was this random function. This is my do twice wrapper. And then, let's see, the task was to apply this to, let's see, roll dice. So roll dice is a very simple function, doesn't take in any arguments, and it just returns a random number. Like this. So now if I roll dice and actually call it, we can see that I get at least what looks like random numbers, like this. And you can see that even though here I'm returning one number, I'm getting two back there. So the do twice thing does something. Let's see, just to spell out kind of what we're doing here, I could also then say that I'll store these as temporary variables. So I could call them first and second, for instance. Like this, and then return first and second. So this might be a more readable way of implementing things. So just to show that that still does the job. You can see that we still get our two results back. Any questions about this? Was it okay to implement? You can kind of see the things how it works. Yeah. Yeah, what's the limit in decorating decorators? Was that kind of the question? No, there's can be turtles all the way down, essentially. So you can have as you say, decorate a decorator if you want. Yeah, let's actually do that right now. We can even we can stack decorators on top of each other. So in this example here, I could, for instance, do a before and after like this. And now if I do my roll dice, you can see that it's calling before after for each of these functions. And the way this works is that you just have nested function calls. So what we have up there in the sort of like the middle of the screen now would be more or less equivalent to doing before and after, and then if we just define roll dice as a regular function, and then we do apply before and after to roll dice, and then we apply do twice to that again. So in this case, you see that the before and after decorator is also then executed twice. If we kind of do the same as there, but we flip the order, then we'll see a slightly different result. So I can do before and after, do twice, and then this. And now if we call it, you can see that the dice rolling is done twice, but the before and after is now only done once, because the do twice is only applied to this one. But yeah, it's possible to kind of stack decorators like this in some sense as much as you want. It does depend then that these are actual decorators that return functions, since we're kind of transforming functions all the way. Okay, any other questions? Yeah.
The idea of decorator to make it then very generic to apply them to all functions, or is not the idea to just limit them to put to some special range of functions?
Right. So the question is whether should decorators be very generic so they can be applied to anything, or kind of be specially designed to things. And in general, you want to, I guess, make them as generic as possible, but not more generic than that. So for instance, say I think in the Flask framework there is a sort of like this login decorator that you can use to check is the user logged in. And that's of course designed to be put on some of these Flask routes, so it's kind of designed to work inside of this framework, and it won't really work if we just throw it on some magic function here. So yeah, it's kind of like function in that sense that, yeah, you want to be fairly generic with them, but not too generic as well. You kind of, they need to do their task. Yeah.
So that we made a device and then inside
Mm-hmm.
that actually runs it twice.
Mm-hmm.
So it actually nested.
Yeah, if you have several do twices. Yeah, so I guess the idea was what happens if we do twice several times. And let's just check this. So it's something like this, right? And now if I roll my dice, you can see that I get two pairs essentially now. And then if I keep doing this, I'll get, I guess next iteration I'll get two of these pairs of pairs, and it kind of just explode out. So do twice, 3 times will give me 8 numbers and so on. Yep. Can you use a decorator from a different class? Yes, if you can kind of name it, then you should be able to call it, essentially. Right, so let's see, we'll have some example later where we use a class as a decorator. But yeah, it's kind of just a namespacing thing. So as long as you're able to reference something that works as a decorator, you can use it. Good. Then I'll guess it's time for a coffee break. So we'll continue in half an hour. And if anyone has any questions, I'll be here. So.
Choose decorators, and these are the areas you should not.
Okay, yeah. Right, so any good rules of thumb for when you want to use decorators, and perhaps when you won't? So one typical use case, at least that I find, is that you have the same functionality that you want to implement all over your code base kind of thing. So I guess one fairly basic example of this would be that you have several pieces of code where you want to, say, time your function or something like this. So I want to figure out how long is the runtime of this part of the code, how long is this part, how long is this part. And then one way to do it would be that you just add in this, what you use, something time.time minus previous kind of thing all over your code. And when you kind of start recognize that, okay, I have the same pattern that I kind of have spread out in many places, then you can start thinking, is this something that I can do with the decorator instead? And just create your timer decorator and just you add timer here and there. And I guess similarly with this login functionality we talked about previous with the Flask and so on, or what they did with this compiler thing that it kind of, so when you start to see that I'm doing the same thing but in very different areas of my code, then maybe that behavior thing is something I can pull out and use the decorator for. So that's kind of the, yeah, it's still somewhat abstract, but one way to recognize it. Other questions? No. So the plan now for the second half is essentially to keep doing what we have been doing, exploring the decorators and kind of grow now from, we kind of figured out how to write our basic decorators. So now how can we do different types of decorators? And the first thing we'll look at is looking at decorators that only do stuff sort of like at defined time. So when you define a function, that may sometimes be useful. And we'll kind of see how that changes the pattern. And then we'll dive into how can you have decorators that have parameters on them. So we'll see some examples of how to add that to things. And then it may sometimes be helpful to have a decorator that can somehow keep state. So hopefully we'll have a chance to look at those as well. So that's kind of more or less the plan going forward. But yeah, we'll keep doing this sort of like with the same fashion. So you get some exercises, then we'll kind of talk about things afterwards. Okay, so I think we kind of left it after we did this do twice decorator. And what I kind of want to go back a little bit at is just make sure that we understand when is kind of the decorator, when is it kind of running? When does stuff happen when you decorate? And we talked about this a little bit in sort of like looking at the syntax, or at syntax versus this high equals something of high kind of syntax. And let's see, if we go back to, I guess I have over here. So I'll just use our old and trusted before and after decorator. And if I add in a line very much on the top, so before the wrapper there, and I'll just say here something like decorating func, and then double underscore name. So this attribute, so I don't know if you've seen these double underscore attributes. There's something called thunder names or special names. So these are typically Python's, they're reserved for Python, so that's why they have the underscores to kind of mark them. And they can often give you a lot of information about, say, the whole data model of Python. So for instance, when you define a function, it has at least some idea what its name is that you can pull out of this standard name attribute. So this print statement is now something that I want to call not inside of the wrapper, but outside. So I'll just see what happens then. So I'll take this, copy this, and let's see. So now I have the before and after. And let's just use this on our good old high thing. I guess we can do the simple high. Something like this. And yeah, let me just call this so we see everything immediately. Yeah, that was the simple high without the F string. Okay, we'll leave that. So what we can notice here, though, is that the decorating high came already when I defined high, right? And this line is what's printed on the top there. So that's the print that's already at depth there. So what we can kind of read out of this is that before and after, if we think of this as a function, that function is executed when we define this, right? And what happens then is that everything that's not inside the inner function there is executed. So the print statement comes here immediately. And then when we're actually running the decorated function, what we're really doing is executing this inner function. And since that print statement is not part of the inner function, we don't see anything about decorating here. Here we just see the before and after that kind of is in between there. So that's kind of just something to, I guess, keep track of, keep in mind. And it means that if we have a decorator where we only want to do something at defined time, so we actually don't want to change the function, we just want to do something when a function is defined, then we don't actually need that inner stuff. So for very sort of like basic example of this, I can pull out, yeah, let's call it define or something. I can pull out this functionality that we just had now with the print statement. So I'll say that this define thing just prints out, whoops, what did you do now? The same print statement that we had earlier, and then I'll just return the original function. So what this does then is that I can use define there, and then I'll define the hi, and then that should print. Let's see if we get this correct. Like this. So what I've done here is that I'm able to do something, ideally more interesting than just printing, but I can do something whenever a function is defined, but I'm now not changing that function at all, right? So here I'm returning the exact same object. So if I do hi PyCon here, we can see that it runs just like this. And if I look at this function, I can see here that this is the hi name function that I just defined. For this latter thing, let's have a look at if I go back to the before and after, and now let me decorate the hello function instead, just so that we keep both of them. So this was the version of before and after where we added the print, so we can see here that that print is run there. But then if I now look at what is this function object, we can see here that hi is exactly the hi function, but hello has become this before and after wrapper function, because that's what we kind of sent back there. Yeah?
So primarily we've been saying that it's kind of adorn functions with text, or surrounded with text.
Right.
But it seems like you could also use it to implement functionality, call stack functions, logging, something like that. Just every time a function is hit, you could have it.
Yes, exactly. Yeah, so the, I guess, comment is that so far we've kind of just been doing this dummy examples where we're printing out stuff, but the real use case for this would be that you can implement some functionality whenever something is called. Maybe you want to do some logging, which is a great example. You can do, yeah, some call stack manipulation, or but we'll come back to some of these. You can do some validation, which hopefully we'll have time for an example at the end, and so on. So yeah, you can do all kinds of stuff with this. One thing that we can see here is that here there's clear proof that we have done something, and it is actually a completely different function object than this thing. And what's kind of happened here is that we have this kind of closure thing where we're saving a reference to the original function, but what we get back in hello here is actually this wrapper function. But then that wrapper function calls this thing here that we don't have direct access to anymore, actually. Okay, and what we're actually seeing kind of leak through here is that this decoration kills a little bit the names that we have for things. And let me just point out that here we see that the function kind of knows its own name, and we can see this. If I can do the under name that we talked about, or that's printed in the REPL when I do this. And we can do the same with, say, print. You can see this knows it's the function print. I can do the name for this. It knows its name is print. But now, if you remember, I had skriv ut, which was just equal to print. And if I do skriv ut like this, you can see it still knows it's print. It's not become skriv ut somehow. And if I ask it here for its name, that's still print. So the name of a function, as it kind of knows itself, may be different from the name that we're using to refer to it. So those are kind of two separate things. Let's see, yeah. So we saw here that when I had this hello thing there, it messed with the name, which may be an issue. If you're kind of using this name for anything, then this will be terrible. For instance, if you're logging that I'm now calling this function, and then suddenly you get this usually not useful information that it's this inner thing. So there is actually a decorator that already exists in Python that can help us kind of keep track of metadata or make sure the metadata here are more well-behaved. So let's go back one more time to before and after. And I'll remove this decorating thing again. That was kind of just to show you. But then I can apply a decorator now to the wrapper function, to the inner function. And let's, first of all, I'll import functools. So this is one of the standard libraries. And inside of functools, there is something called the wraps. And if you just look at the help text for this, we can see that this is what they call the decorator factory. Think of it almost like a decorator. We'll soon come back to exactly what it is. But this one can then essentially, this is fairly technical, but it's, okay, this is too technical for now. What it does is that it changes name and so on, so that the decorated function looks like the original function. So let's have a look at it. If I do functools.wraps up there, and then I actually need to pass in the original function as func there. And I see that VS Code is yelling at me because I haven't imported functools. Okay, so now let's have a look at what happens if I use this one. So I once again redefine my before and after decorator, and now I can use this again on the, well, let's use it on high. Before and after, def high, print high. Because now remember, hello is kind of still the old one, so it has this weird name. But now high, even though it has been decorated right here, it looks like it's just a plain function. It kind of kept its logical name, so to speak. So that's, on the very top there, you see this functools.wraps. Its task is essentially just to keep the metadata, or pass on, really, copy the metadata from the func that's passed in to the inner function. So that it's usually at least a good idea whenever you have a decorated wrapper like this to just throw the functools wraps on top of it. That kind of makes things play nicely together. I think essentially the only thing is if you don't have an inner function, so you don't change the func. But I think always do it. And if there's an exception, you'll probably figure it out. Okay, so I think that brings us to a new exercise. And this one might seem like yet another of these dummy examples, but this one is probably the decorator I've used the most myself, and it's actually a fairly powerful mechanism for doing sort of like plugins where you can kind of inject code and things like this. So what we want here is to write a decorator that stores references to decorated functions. So we don't want to change the decorated function at all, so it's similar to what we did with define, but we want to just keep references to them. So in this case, our test is that we'll just, okay, let's create a global dictionary, and then whenever I define a function that is sort of like has this register decorator on top, it adds a reference to the function in this functions dictionary. So have fun with this one, and then we'll talk about it more in 5-10 minutes. Okay, then we're starting to have at least some implementations. Did this work out fine for you? I guess we'll discuss a little bit now, so we'll see. So the idea here was that we will, let's see, look at the question again. So I want to define this register decorator that doesn't really touch the function at all. It just makes note that this function exists, essentially. So that means that we only need to do something at define time, so we don't need to change the function. So we don't actually need to use that wrapper that we have been using so far. So this will turn out fairly similar to this define decorator we did. So let's see. I can then do something define register. And then what I wanted to do now was to just make a note in this functions thing. And here we can use the dunder thing. So I'm just saying that, okay, I'll use the name as the key, and then I'll pass in a reference to the function. So make sure we're not calling the function, right? We're just storing a reference to it. And then I should here also return the function itself. So this is kind of the decorator that we're looking for. I should also, yeah, we'll run it afterwards without returning func, just so you can see what happens then. And let's see, before I can actually use this, I also need to define functions. So I'll just let that start as a global dictionary here. And let's see, was it the dice rolling example again we did? Yeah. So if we do register, dice roll, and then we return random rand int, like this. So what has happened now is, since this is define time, right? So we not need to call anything. So when we did register there, then this functions thing should have been populated. So let's have a look. You can see now it's no longer empty, but it has a reference now to the dice roll function. And since this is a function reference, we can again start playing with it. So I can't pick it out here. So there's my function reference, and then I can call it. And we can see that I get some random dice rolls here. So this is really, let's see, where are you? There. If we're just doing something at define time, then this is enough. We don't need to wrap anything because we're not changing the function. So it just stays the same. So if I look at the dice roll function, we can see that it has its nice name here, and so on. Let's see, so yeah, first, if I wouldn't, let's see, so if I do def register, and I do this, but I don't return anything, what do you think will happen then? Anyone want to guess? The function will register, but I can't, what do you say? But I can't use it, essentially, right? So let's try that. So, okay, I'll redefine functions as the empty dictionary, just to see it's empty. And then I use this bad register with my dice roll, like this. So you can see now functions has the dice roll implemented there, so that's beautiful. And we can even call it, so we have the reference there. But now if I look at dice roll itself, you can see, well, nothing seems to be there. And if I check slightly more closely, we can see that it has been replaced by none, since we're not returning anything. So when we do a decorator like this, it is really replacing the function we're decorating with whatever is the return value of our decorated function thing. So since we didn't return anything, Python implicitly returns none, so we get none back there. So this, I guess, might be a feature because it means I can't call it like this. It kind of forces me to use the functions thing there. So maybe that's a feature, maybe it's a bug. Then just lastly, I claim that this is a very helpful decorator. It may not seem like it immediately, and I don't want to kind of dive too far away from the decorator stuff. But what we can kind of do with this is that we can then dynamically call functions without having to kind of specify it beforehand. So for sort of like still a fairly silly example, but I could then do something like this. Which function do you want to call? And then here I can say dice roll, and then essentially we'll do something like functions name call. So here I kind of somewhat interactively defined which function I want to call, and then if you have several defined, you can kind of use this. For maybe a better example of this, say that you have different file formats that you want to read. And then you can kind of define a handler for, say, CSV format, another one for JSON. And if you just register each of them, and then you can kind of call them indirectly using something like this, then it makes it very easy to then later just patch on another file format for you. Then you can, anywhere else, you can kind of register a handler for YAML or something like this. So it kind of allows for, very flexible ways of structuring your programs. Okay. That's not what we wanted. Let's see. Then we talked about those. Yeah. So one thing I guess I'll also now just point out. Let's see. The high function, I should have pointed this out earlier. I just want to show it to you, and then we'll look at this more closely later. But the high function was one of those where we used this wrapper. And it's actually possible to access unwrapped like this. So this is one of these before and after. So if I do high PyCon, right, we do the before, high PyCon after. This wrapped thing, you can see it seems to also be the same function, but it's actually then the inner function. So that's another bonus with using this wrapper, is that you can actually access the original function quite easily as well. If we have used functool wraps, then diving in through wrapped, then you can get access to the original undecorated function. Okay. I think we can then move on to the next exercise. Are other questions, comments? No? Oh, yeah. What would be a use case for accessing the wrapped thing? Well, usually you have, I guess, wrapped things for a reason. You kind of decorated them because you want to use it. So typically it's not something that you'll use. But it could be a way, say, that you can sneak through in a login example, if you just want to test something. So don't do it in production, I guess. You could then sneak through the login stuff by going beneath it, or if you don't want to time something that has the timer on it. But yeah, now in general, it's more know it exists kind of thing. Okay, so I guess in keeping with somewhat silly test functions, I've here changed the roll dice function so that it creates an error if you roll less than 5. And then what we want to try to do is to create a decorator that just retries a function call if the function call fails. So in this case, when we run this thing, we should get either 5 or 6. We should not get the error message. And then, yeah, this is a silly example. Look at slightly better examples once we have the retry decorator. So yeah, have some fun with this one. Okay, I guess we can start to have a look at this. So this one will again be sort of like a regular decorator where we're kind of needing to do something. But now I guess, well, we can think of this as doing something more or less after calling the function, where we're catching an exception and then potentially running it again. So let's see, one way to solve this then would be that I can, let's see if I move this up a little bit. So I'll define the retry thing, and then as we've kind of learned, we can add a wraps there, and then we can define a wrapper. So I'm kind of just throwing in the template, more or less, we have by now. And then here we'll do something, and then we'll return a wrapper. So this is kind of just the template part. And then what did we say we want to do here? Essentially, I want to call the function repeatedly until it doesn't return an exception, essentially. So in this case, I guess I can just throw myself into a while true loop. So I'll just run forever. And then I'll try to call the function. Something like this. And here I just return immediately the value, so I don't need to do anything else with it. So the only problem is if this thing now raises an exception when it's called. But that's something we can catch with an accept clause. So I'll just accept the exception. And then if we get an exception, I just really want to keep moving. So for now, I'll just do a pass statement there, I guess. I think this is probably the most basic thing we can do with the retry, and then we'll add in a little bit more functionality to this after a while, but let's see if it works. So I'll put this into our REPL, and then our test was to see if we could keep rolling and only get 5 and 6 in this. I guess I called it only roll highs, but it's really just our dice roll thing in hiding. So we'll have some number that's a random int. And then I said if number is less than 5, then we'll raise a value error. Let's see, were we more fancy with this? No. And then I'll just return this number. So now if I run this, only roll highs, we can see that, okay, I got 6, 5, 6, 5, 6. So I'm not getting the 1, 2, 3, 4s that should be there. So now everything kind of happens so quickly that it's kind of hard to really see what's going on here. So let's change this in a little bit, just add a little bit of visibility into it. So when we get the exception here, I'll also print out that something bad happened. So retrying. I guess we can be talkative and say func name. because of E or something like this. So now if I run this one, and then I'll just do, no, this is easier, let's see. So now I redefine my only roll highs, and then, okay, come on. If I run this, you can see now that we see some traces of it actually re-rolling the lower things. Now, of course, this is a completely silly example because I could just have my random number generator give me 5 and 6 directly. So just to show you an example where something like this might be useful, and I think just to kind of be a little bit nice to the system, I'll also add in a small delay. So we can do something like time sleep, say for 1/10 of a second or something. So if we use this, and then let's see, I'll do the only roll highs. So now you can see it just takes a little bit of time in there. So now this is something that we could, for instance, use to poll for resources maybe that we know are coming, but they may not still be there or things like this. So to do a small example of that.
Quick question, sorry.
Yes, please.
I think I can accomplish with a try accept else and then running wrapper again in the accept clause. Like is there anything like this? Is that a weird way to do it?
Ah, nice. Okay, so the example Martin is showing here is that he essentially calls things recursively, I guess. So instead of doing the while true loop, let's just, yeah. So instead of using a while true loop here, it just calls the wrapper itself in the accept block. And that also works, except that I guess Python has this recursion limit. So I guess it will fail after 3,000 attempts or something like this. But yeah, in general, it's possible. I guess in Python, again, function calls takes a little bit longer. So doing a while loop is probably better, but it definitely works. Okay, then the example I want to move into was to try to use this for some kind of system polling, just to see a slightly nicer use of this retry thing. So let me see. I'll use an example where I'm just trying to get the file from my disk. So I'll do a pathlib operation. And let me see. Then I can retry. Something like, well, let's say, well, let's call it process file. It sounds like we're doing something interesting. So we're getting a path, and then let's just print out the content of this file. So I'll do something like path read text. And now I could then do something like process file, and then I'll throw in a path there, so path lib path, and I'll give it the PyCon.txt file. Now this file doesn't exist, right? So it just tells me here that I'm trying to read this file, but I can't find it. What I can do now, and let's see if we're able to do this. Yeah, I'll do this in the black so we kind of see the background there. And I think this is the directory I'm at. So let's see if we, yeah, so I'll add some text just into a file here. Hi, everyone. Have fun at PyCon. Okay, so this is just on Linux. I'm just creating a text file that I just for now call text, and it has this content. So now if I change the name of this file into pycon.text, then the process that's kind of running in the white screen should be able to pick that up when it becomes available, right? So let's see. So I'll rename text into pycon.text, and now hopefully I'm in the right place. Oh, yeah. There we go. Yeah. So this is kind of one way to kind of, you can kind of poll for resources that ideally you know are coming, right? And this could be then on a local directory or out on the web or stuff like this. But when doing this, it's nice to have these sleeps in between so you're not completely overpowering your system. I guess a similar thing we could try is this becomes kind of somewhat too simple, maybe, validation, but I could have some function where I'm trying to get some information from the user. So say that I just want to read, say, a number, age, or something like this. And then actually, before doing this, let me actually do this example without the, okay, so I'll do get age, and I'll say that this just returns int input, how old are you? Something like this. So now if I do this, so I guess Python is 20 years, right? So we can say 20, and it returns 20. But if we do something like 20, you can see here that I get an error because I'm doing this int conversion up there. I'm converting this to a number because I want to use the number. So one way to kind of avoid this is that I can define the get age with the retry. Like this. And now if I do get age, and I claim to be 20, it says that, okay, I'm retrying get age because I got this bad thing there. So now, okay, I'll behave properly. So there are some uses, at least, where you can play with this. Okay, and now for the fun part. Or first.
What if I wanted the number retry?
Ooh, you were 5 seconds ahead of me. Perfect. Yeah. The pathlib? Yeah. Did we use pathlib? So I imported pathlib, and did I use it? So I very briefly used it here. So here I passed in .path. And then when I defined this process file function, let's see, let's just look at it here. So there, this read text method that I use is a pathlib path method. Yeah. Okay, and then, yeah, for the fun part. Sometimes we want to add parameters to our decorators. It's also not the functions we're decorating. Because we may want to have some different behaviors. So let's see. I have two versions of this. Let's actually just jump directly to the one that Glenn wants to solve. So we want to adapt retry so that it only tries a maximum number of times. So then if we do apply this on our only roll highs function, then we could get 5, 6, or we could actually get the error if we don't get the number within the max number of retries. This exercise, I'll give you a few minutes to ponder it, but there's, I guess, a few things I have told you, but I haven't really told you in how to actually make this work. But think back to what we did earlier with the function factories and those kind of things. Because what we really need to use here is that this retry becomes a decorator factory, so something that returns decorators for us. So for each parameter, essentially, of max retries, we'll have a different decorator. is kind of what this ends up being. So yeah, try it out and then we'll look at it together afterwards. Yeah, so how's it going? This one is definitely the hardest exercise so far. So let's have a look at see what we can do with this. And we're kind of, yeah, there's sort of like a new idea that we haven't really talked about. It kind of was just mentioned. So let me find my editor. So essentially what we kind of know how to do now is this, okay, we can run this for everything, but I want to add in some kind of parameters somewhere that I can use to kind of say, I only want to run this n times or something like this, so I have a maximum number of retries. And let's see, so that means that I want to be able to send a parameter to retry itself. So somehow it should say max entries there, right? Max retries, thank you. Retries, that's how I spell it. So that's kind of what I know I want this to look at, and that means that when I run it, or when I use it, I should be able to do max retries equals 3 or something like this, and then we'll have our function beneath here. But how does this then, if we look at, so what we've kind of said so far is that typically when we have a decorator, it should look like this. So we have func tools, let's see, dot wraps, func, and then I'll have my wrapper thing here. So this is me just kind of filling out the template that we kind of found so far. Do something and return wrapper. So now I want to do this, but I also want to do that. So I kind of need to put those together somehow. And what I said was that this new retry decorator here becomes like a decorator factory, which is similar to what we did with these function factories in the beginning. So if you remember, all the way up here, we kind of had this prefix factory that dynamically created a new function for us, or reverse factory, which kind of did the same thing. So that's kind of the idea that we'll use here as well. And what that means is, let's see, where are we? Here we are. That I still want this to be a decorator, but this is actually the thing that will be dynamically created. So this retry that I have there will be the retry decorator. So I'll just rename it and call it Decorator, like this. And this will be an inner function thing. So it will be part of this retry. And then at the very end here, I'll actually then do a return decorator. So this is definitely when sort of like our brains get somewhat overloaded and things like this, because now I don't not only have an inner function, but I have an inner function. So kind of keeping track of this is not trivial, right? But what this means is that where we earlier just had retry like this, now this full expression, retry max retries, is what, let's see, that returns the decorator func, and that decorator func returns the wrapper. So we're kind of back to where we started. So if we want to have decorators with parameters, then typically what we'll do is that we'll kind of push in a template and have this factory outside of it. Okay, so when we have this setup ready, then actually implementing this is very similar to what we did earlier, except for now, instead of having this while true loop, I can just do for, say, I in range max retries. And then I realize I'm never going to use this I, so I just call it underscore instead. And then I'll try to return. So this is the same code that we had earlier. Try to return a func. And if that fails, I'll print that it failed. Let's see, what was the text we used? Retrying. Retrying. Func name. And then, yeah, let's throw in the error message there as well. So then I have exception as E. And let's see. Yeah, this is close to something that works at least, so let's try it out. So if we now copy this, and then I can use retry, but I'll only do, okay, let's max 2 of them, for instance. And then we'll do the only roll highs. And let's see, that was number. And if that number is small, then we'll raise the value error. And otherwise, we'll return the number. Like this. So now I have this function that rolls the dice, but raises an error for smaller numbers. But now we say that I only want to retry this twice, so let's see what happens. Yeah, so you could see that the first 3 times I ran it, it tried twice because I won 1 and 3, 4. One challenge here is that it doesn't actually raise the error. The error is kind of eaten up, which I guess may or may not be a good thing. So we could potentially just change our function so that the last time we call it, I guess, we don't protect the error. So I could do something like, okay, I'll do this max retries minus 1 there, and then I'll just add in a, at the end there, I'll return. So my last retry, I don't protect it with the try block. So then if it fails that last time, then we see the error itself as well. So just to demo that. So you're doing that to return an error, right? Yeah, since maybe that error is nice to get, I guess. So let's see now if we only roll highs. There we got the 5 in the second roll, 6, and there you see it now I get the error after retrying a few times. So that may or may not be a good thing, I guess. The previous example just returned none at the end. Yeah?
Could you also substitute else at the after the for loop and print just max retries reached or something like this?
Right, so can we do some, like an else after the for loop? To get to the same thing, potentially. So here I have my for loop. So the else statement, I don't know if everyone's familiar with else in for loops, but it's possible to do an else here, so kind of lining up with the for. And that else loop, let's see, that kicks in if you go through the loop without breaking out of it. Since we're now just returning from there, I guess, yeah, let's see. So if we, instead of returning this, yeah, so let me actually copy this so I don't mess up the previous example. Let's see, so this one didn't have an else. Yeah, so if we have the else there, and then we could just say print max retries. Max retries done or something like this. And then we go back there. Yeah. I think this should look nice as well, right? And I guess technically we probably don't even need the else there since we're returning and not breaking. So that would look like this, and then let's throw in this one. So So are we able to break it? There we go. Ah, yeah, I forgot my F string. So, but yeah, this would be another alternative of kind of alerting someone that we're done. Cool. Yeah, so this is then the principle, essentially. If you want to have a decorator that takes an argument, then essentially just add another layer of stuff on top of it, which then becomes this decorator factory. And now I guess I can show you, I claimed that, which was it, functools wraps, that this one wasn't, it was a bit too technical, but here you can see that this is actually a decorator factory, and we see that it takes an argument, right? It takes the func and so on. So, okay. We're running close to the end, so we have like 17 minutes left. So I think for the last exercise we'll do, let's see, let's maybe just do this one. So can we make retry have state, essentially? So instead of just saying for each function call, it can only do 3 of these. Can we, and in this case, I guess max retries may not really make sense, but can we make it just count how many times it has retried across all kind of different function calls? So that would mean that somehow we need to keep state. And there are kind of a few ways to do this. So one would be to have some kind of global variable that kind of does it. That's typically not a great idea. A better idea would be to use some attributes on your function where you just store that state. And then, yeah, the third example would be to actually create a class. And I'll definitely, I don't know if I'll have time to demonstrate this, but I'll definitely leave some notes about how to use classes for decorators. Because so far I've claimed that the decorator is a function that returns, well, takes in a function, returns a function. But it's really enough that it's a callable, and you can have class instances that you can kind of call. So you can use classes as decorators as well. So in some of the notes, I'll share links with you afterwards. You can see how to do that. But now, yeah, for sort of like the final example, can we just put a counter on our retries that will then globally count how many retries we made? So we can adapt the code that we already wrote, so it's just a few more lines, I guess. So I'll leave this, since we're almost out of time, but I'll leave you with 2-3 minutes to play with it, and then we can look at that. Okay, I guess then so we finish on time, I'll just start working on this. So I'll show you the solution where we put this as an attribute on our decorator. And let's have a look at this. So we have our retry. So we won't change this function a lot. Let's see. But what we can do, which maybe looks a little bit weird, is that it's possible to add attributes. And we have actually seen this briefly. If you remember, this functool wraps adds this standard wrapped attribute. So for instance, let's see, if we had the only roll highs, we should be able to do to look at this, right? So somewhere this attribute has been added. So we can do something similar here by, after defining the wrapper function, we can say something like number of retries is 0. So now I define an attribute on this wrapper function. And for now, I'm not using it, so this is we're not done with the implementation, but let's just have a look at what happens. So I'll move this over to my REPL, and then we'll implement the only roll highs again. And now if I look at only roll highs.numRetries. Have I messed up something in numRetries? Sorry? Max retries. Ooh, I copied the wrong thing. Impressive. Thank you. Okay, let's try again. Now it's there. And then let's see. Then I have this and this. Yes. Okay, there it is. So this retry decorator, because of this line up there, adds the numRetries attribute. So that means that we're kind of storing this state on the function itself instead of kind of polluting the space. So then our next task then is to actually use this. And let's see, what did I actually want to do with this? Well, I could now, let's be slightly advanced then and say that I want to do max retries, but then subtract the number of retries I've already done. So I can do num retries there. And then I need to actually count these things. So then I'll say wrapper.numRetries plus equals 1 there. And then retry func name. Yeah, I'll just throw it in here at the beginning so that we can see it. Wrapper numRetries. Yeah, so this becomes a little bit of a long line, so let's see. Okay, I'll leave it like that for now. So now if we copy this, so now there you can see I added, let's see, in the for loop, now I'm just doing max retries minus the number I've already done. And then in the exception, I'm printing out this number, and then I'm adding 1, so I'm counting them. So then if we do the decorating, and now let's add this number a little bit higher, so we can do 10 retries. Okay, and then I say I only want to roll highs, and call this, and now I got a 6, and there you can see it's kind of doing some of the retries. I guess I should have added before printing the number, but something like this. And now we can see that it has state, right? Because it continues counting at 2. And if I look here, I can see that I now have done 3 retries. And if I now do this a few more times, 4, 5, 6, 7, 8, 9, 10, then we can see now I get the 10 retries done. So we kind of have kept the state across several invocations, even without using a class. Yeah, let's look at the code for this. So now we actually managed to more or less fill our screen. So I guess the somewhat magical line is here, where we can add in our attribute, and then I'm using that attribute a few times here and there. Okay. Any questions? I'm sure there probably are. So, but if you, yeah, they don't pop up now. Feel free to stop me if you see me at the rest of the conference, or send me an email later or something like this. As I said in the very beginning, I'll put on all the code on my GitHub. So I'll let's see. Let's switch this to the resources. So, yeah, on github.com/Hjelle, G-A-Hjelle, you should be able to find these things. I've given a similar course when PyCon was online, so there are some of these video courses that's also there, and then I'll add the code from this course. onto there. I guess I didn't say this at the beginning, but on my day job I work for Real Python, which is a website where you can learn a lot of different Python stuff, and including then we have an article about decorators that I wrote a few years ago where you'll find a lot of the same material there. And within sort of like the paywall, you can also find a video course that goes through a lot of the same things. Then there are some other nice places online, of course. If you really want to look at the technical details, you can have a look at the PEP 318, which is kind of spelling out some of the history why they wanted to do decorators and how they work. That's also, I think the fun part there is probably reading some of the stuff that wasn't accepted. And there's an awesome list for decorators. That's also on GitHub. So yeah, there's still lots of things to explore. But I think that kind of takes us to the end. Any questions? Sorry? Yeah, so I'll put the exercise slides there as well. Yes, exactly. And no, well then, thank you everyone for your participation. It was really great. Thank you all of you for uploading your solutions as well. Yeah, it was really nice to at least get some sense of the activity, so thank you. And thanks.